In order to understand negative exponents, we just need to extend the patterns that we looked at for zero exponents and see what the results are. So let's take a look at this pattern. We'll start with 16, 8, 4, 2, and 1. And then let's think about what the next number in the pattern would be. Well, if we keep dividing by 2, 16 divided by 2 is 8. 8 divided by 2 is 4. Divide that by 2 to get 2. Divide that by 2 to get 1. And if we divide 1 by 2, we get 1/2. And half of a half, in other words, dividing a half by 2, we get 1/4. And then 1/8 and 1/16, and so on. Now let's look at different ways of representing these numbers. So we can take 16 as 2 to the 4th, 8 is 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0, and then we can think of 1/2 as 1 over 2 to the 1. 1 over 2 squared, 1/8 is 1 over 2 to the 3rd, 1/16 is 1 over 2 to the 4th. A third way that we can look at this is, we'll go from 2 to the 4th up to 2 to the 0, and then really the next logical pattern for the exponents is -1, so 2 to the -1, 2 to the -2, 2 to the -3, 2 to the -4, and so on. So this is how we find meaning in the negative exponents. So far, we see that 2 to the -1 is equal to 1/2. 2 to the -2 is equal to 1/4, or 1 over 2 squared, and so on. Now let's see if this also fits with the pattern of adding exponents, the way we looked at for zero exponents. So remember that when we were looking at zero exponents, we wanted to solve the problem 2 squared times what equals 2 squared. And we felt that 2 to the 0 was correct, because this also equaled 2 to the 2 plus 0. Now, let's reverse this a little bit, and let's say 2 squared times what equals 2 to the 0. Well, if we look at this as just numbers, this would be 4 times what equals 1, and the logical choice would be 1/4. But if we're also to apply the rule of adding exponents, 2 squared times what equals 2 to the 0, well, this would have to be 2 to the -2. So there we also see a justification for 2 to the -2 equals 1 over 2 squared, or 1/4. So with this interpretation of negative exponents, this seems to make sense. So now, let's put this into some context. So, we will say that 2 to the -3 is equal to 1 over 2 to the 3rd. 5 to the -4 is equal to 1 over 5 to the 4th. There's another way of looking at this. 2 to the -3 is equal to 1/2 cubed. So what the negative exponent did was we took the reciprocal of the base and raise that to the third power. If we state the rule in a general way, a to the negative n power equals 1 over a to the n, and also equals 1 over a to the n. And in the next video, we'll look at ways of applying these properties to simplify expressions.